Hello, everyone, and welcome to Server Network Technology by Odeon, Lacey, Francina, and Matt with the Department of Library Sciences and Technology at Sam Houston State University. In ISDT 7315, Educational Network Design with Dr. Thomas Edelberg in the fall of 2025. Today, we'll explore what a server is and why it's essential to modern instructional technology. Drawing from Trends and Issues in Instructional Design and Technology by Reiser, Carr-Chellman, and Dempsey, I'll connect the technical concept of servers to the realities of digital learning environments. Servers form the hidden backbone of nearly every digital learning environment. A server is a specialized computer system that stores, manages, and delivers data or applications to other devices on a network, ensuring that students and educators can access learning materials anytime and anywhere. In instructional design and technology, servers are not just technical hardware, they are infrastructure that supports learning management systems, multimedia delivery, analytics, and emerging tools like AI tutoring. As Reiser, Carr-Chellman, and Dempsey in 2024 highlight in Trends and Issues in Instructional Design and Technology, understanding how servers operate is essential for designing reliable, scalable, and secure digital learning experiences.
Thanks, Lacey. Now let's talk about the server basics. So powering instructional technology from behind the scenes. Now let's discuss the client server model. So what is a client server model? Well, this is really the backbone of the learning systems that we use as everyday professionals in the realm of education and in corporate settings. When a student or a learner opens a course module or submits an assignment with their device, the client sends a request to the central server. The server then processes that request and sends the appropriate content or the data back to the user in just a matter of seconds, according to Maud Macer et al. In 2021. To continue with the basics of server concepts, let's take a look at cloud housing and flexibility. So cloud housing is how most modern learning management systems now operate. Instead of running servers locally on campus, many school districts are now relying on cloud-provided servers such as AWS, Azure, and Google Cloud to store content and deliver it to their students and teachers, as supported by El Koshri et al. In 2024. One of the biggest benefits for these school districts with outsourcing this to the cloud is a reduced maintenance for on-site IT teams. Updates and patches happen automatically, which means fewer outages and less time spent troubleshooting hardware. Cloud hosting also allows systems to scale quickly. So for example, when thousands of students log on at once or one given platform at one specific time or for registration periods, the system has the capability of handling increased demand for all of the users at one time, as shared by Ahmed et al. In 2025. The third basic server concepts are centered around bandwidth and latency. These are two key factors in how smoothly learners can access the course content. So bandwidth, we've all heard that in one way, shape, or form. This is truly the amount of data that can be transmitted per second. Ahmed et al. In 2025 shares that higher bandwidth allows for faster loading times, which is especially important for video-heavy courses and interactive stimulations in the learning environment. Latency, on the other hand, is where is the time that it takes for data to travel between the client device and the server. Even a delay of a few hundred milliseconds can make a live session feel choppy, and the user can sense that if there is a lag.
Thanks, Matt. In multi-server network environments, especially within edge computing architectures, ensuring user privacy during authentication and data exchange is a critical challenge. Hsu et al. In 2020 addressed this issue by proposing a privacy-preserved end-to-end authenticated key exchange protocol designed for multi-server systems. Enhances privacy by preventing identity exposure and resisting various attacks. such as replay, impersonation, and man-in-the-middle attacks. It achieves this through dynamic pseudonym identities, elliptical curve cryptography, and mutual authentication mechanisms, ensuring that both users and servers can securely verify each other without revealing sensitive information. This approach significantly strengthens privacy and security in distributed edge computing networks where multiple servers interact with numerous users across potentially insecure channels. Hsu et al. In 2020 also talks about preventing identity exposure through dynamic pseudonym identities, which replace static user identifiers with frequently changing aliases. Using elliptic curve cryptography, or ECC, for efficient and secure key exchange, and enforcing mutual authentication mechanisms, ensuring both user and servers verify each other before any data is exchanged. The EdTech Developer's Guide complements this technical foundation by emphasizing best practices for privacy and compliance in educational software. Data encryption is where all learner data, especially personally identifiable information, or PII, must be encrypted during transmission to prevent unauthorized access. Authentication and access control, role-based access, ensures that students, instructors, and administrators have permissions appropriate to their roles managed securely on the server. Compliance with laws gives developers a must understanding and comply with regulations such as FERPA, the Family Educational Rights and Privacy Act, COPPA, Children's Online Privacy Protection Act, CIPA, Children's Internet Protection Act, and the PPRA, Protection of Pupil Rights Amendment. These laws govern how student data is collected, stored, shared, and protected, and noncompliance can result in legal and reputational consequences. Minimize data collection to only what is necessary. Collecting excessive data increases the risk of privacy breaches and regulatory violations. Developers should identify the minimum viable data set needed for the app to function. Avoid collecting sensitive information unless absolutely required. Use de-identified or pseudonymized data whenever possible to reduce exposure. For example, instead of storing full student profiles, use dynamic pseudonym identities, as proposed by Hsu et al., to represent users during sessions. Transparency builds trust and ensures compliance with laws like FERPA and COPPA. Developers should clearly explain what data is collected, why, and how it will be used. They could provide accessible privacy policies and data usage summaries, offer opt-in mechanisms for features that require additional data collection. Privacy should be a core design principle, not an afterthought. This includes implementing end-to-end encryption for data in transit and at rest, using role-based access control to restrict data access based on user type. Learner analytics is a powerful tool in modern education. Learner analytics refer to the collection, analysis, and reporting of data by learners and their contexts, with the goal of understanding and optimizing learning and the environment in which it occurs. In server-side learner analytics, data is collected and processed on centralized servers rather than on individual devices. This allows for more scalable, secure, and integrated analysis across platforms and users. It supports real-time feedback, personalized learning pathways, and institutional decision-making. According to the U.S. Department of Education in 2020, digital learning environments benefit significantly from robust infrastructure that supports data collection and analysis. This includes high speed internet, secure device management, and interoperable systems that allow data to flow between learning platforms. The design of analytic tools must be grounded in educational research and user centered design. As emphasized in the EdTech Developers Guide from the U.S. Department of Education in 2015, effective tools should be based on learning science, support formative assessment, and align with instructional goals. Moreover, learner analytics must be implemented ethically, respecting student privacy and complying with laws such as FERPA and COPPA. Transparency and data protection are essential to building trust and ensuring responsible use of educational data. In summary, server-side learner analytics is not just about data, it's about using the data to empower students, support teachers, and improve educational outcomes.
To take a look at practical leadership considerations, as a group, we strongly felt that strong leadership is essential for successful server network implementation. It is not enough to just install the technology, to set it and forget it and walk away. We feel that leaders must create an environment where teachers, students, and IT staff all equally feel supported and encouraged to use the tools effectively at their disposal. The EdTech Developers Guide points out that leadership plays a key role in promoting adoption and continuous improvement, not just the development or the deployment. Ultimately, the choices that leaders make directly affect the reliability, security, and the long-term sustainability of this network. That concludes our presentation. Thank you, guys.